My name is Philip Prentice, and today I'll be presenting my energy momentum project of the case of a gangster and the gun. Now, in this case, where I am a scientific advisor for a show called the Telltale Testers, where they analyze certain stunts and effects movies play in order to show if they're realistic or unrealistic using physical concepts. Now, in this case, I've been offered the position and job to present a situation where gangsters get shot in movies and get thrown far distances, like you see in very classic movies and very old movies, such as Dirty Hand and Taxi Driver. Now, in order to set up this problem, we need to know what our known factors are, and they give us some known factors. We know that the type of gun we're using will be a .44 caliber Remington Magnum gun with a bullet mass of 14.58 grams and a muzzle velocity of 374 meters per second. Now, we assume that the gangster's mass will be around the average mass of a human, which is around 80 kilograms. And we know that before the gangster gets shot, the gangster will be at rest, meaning it would have zero velocity. Knowing all these known factors, we need to know what the final velocity of the gangster would be after being shot by the bullet in order to calculate the distance he or she actually travels when getting shot and to show if it's realistic or not. Now, in order to do this, we need to use conservation of momentum. And conservation of momentum will allow us to find that final velocity the gangster goes after being shot. Finding that velocity, we can use simple kinematics to find our distance the gangster travels and to prove whether the distance of travel is actually true. Now, we know that in our situation, the collision between the bullet and the gangster is completely elastic, since there's very little air resistance on the gun to the bullet to the gangster, and no friction at all. So knowing this, we know that conservation of momentum will work perfectly. So in order to set up our equation, we need to go to our problem. Hi. So now, to explain the situation, I'm going to be using my brother's whiteboard that he doesn't know I'm using, but we will go ahead and use it. So, to start off, we need to establish our known factors. So we know that the mass of the bullet, which is we're going to call it MB, is going to be 0.0146 kilograms. So that's our mass of our bullet. And we know the velocity of the bullet. Velocity of the bullet is going to equal our muzzle velocity, which is 374 meters per second. We also need to establish the mass of our gangster. So the mass of our gangster is going to be called mg, which, as we said, was 80 kilograms. We also need to set our initial velocity. So we know that the mass of the gangster is going to be at rest, so the initial velocity of the gangster is going to equal 0 meters per second. Got the board breaking now. But, so we need to know the velocity of the gangster final. This is essentially what we're looking for. So in order to find that, we need to make a little few adjustments. Make these a little even smaller. We need to set up our equation. So in order to set up our equation, we know that we need to set the total initial momentum before the collision will have to equal the total momentum of the gangster after the collision, or after the gangster gets shot, in other words. So in this case, we need to know the total momentum of the bullet plus the total initial momentum of the gangster, which will basically be 0 because he has zero velocity at first. So the equation will be set up as this: mb, the mass of the bullet, times velocity of the bullet plus mass of gangster times velocity of gangster initial will equal, since the bullet will be inside the gangster after getting shot, the mass of the bullet has to be taken into consideration after. So we need to add the mass of the bullet plus the mass of the gangster, all times the velocity gangster final. So this is essentially what we're looking for, the velocity final of the gangster. So in order to manipulate that, we need to divide the mass of the bullet plus mass of G to both sides. Now, this equation will equal, since the velocity of G will equal 0 meters per second, this essentially will cancel out. So velocity G final will equal mass of the bullet times velocity of the bullet, which is essentially the initial momentum of the bullet, all over the mass of the bullet plus mass of gangster. If we implement these numbers, we have final velocity of the gangster equals mass of the bullet, which we said was 0.0146 kg times the velocity of the bullet, initial velocity of the bullet, which is 340 meters per second, over the mass of the bullet, which is essentially the same, 0.0146 kg, times the mass of the gangster, which is 80 kg. Now, when we implement that into our equation, we can get that final velocity of the gangster will equal 0.068 meters per second. Sorry, it's a little messy, excuse my writing. So now that we know that the velocity is that, we can use kinematics to find the distance which travels. So we're going to do that. Let's erase this because we're working with very little space here. In order to do this, we know that the final velocity of the gangster is going to equal 0.068 meters per second. Now we need to know the time in order to cancel seconds. In order to know time, we need to use the equation velocity G final, which is the final velocity of the gangster, equals velocity gangster initial, which is 0, plus acceleration. In this case, he's falling downward, so it's G times time. Now, this will cancel out since it's 0, and time will equal the final velocity of the gangster all over G, making time equal 0.068 meters per second over 9.8 meters per second squared, considering that meters per second and just leaving seconds, and giving us a time of 0.0069 seconds. So that's our time. Now, in order to find the distance, we can also use kinematics. So we could do this on the other side. We need to use the equation x, or we could use the equation x, final velocity of gangster, initial velocity of gangster, plus the final velocity of gangster, which essentially this would cancel out since it's 0, over 2 times time, meaning that x will equal the final velocity of the gangster, 0.068 meters per second over 2 times 0.0069 seconds. Once we calculate this in our calculator, we get a distance of 0.0002346 meters. We get a distance of 0.0002346 meters, meaning that the distance that a gangster getting shot is very minimal to the ones that we saw in the video, which I will show after this clip. Now coming back here, we can conclude that in gangster movies such as Dirty Harry and The Taxi Driver, where gangsters get shot and are thrown far distances, is not realistic. We know this because we were able to use conservation of momentum to prove it. Since we know that the collision was elastic, the total momentum before and after the collision of the bullet and the gangster will be the same. That being said, we were able to make an equation, mass times the velocity of the bullet plus the mass of the gangster times the initial velocity of the gangster, which was 0, equals the mass of the bullet plus the mass of the gangster times the final velocity of the gangster. When we were able to find that final velocity of the gangster, we were able to use simple kinematics to find the distance of which the gangster traveled after being shot. We found that the distance was 0.0000234 meters, which is nothing compared to the distance that they travel in movies such as Dirty Harry. Now, thank you for watching, and that concludes my project for the case of the gangster and the gun.